Well, howdy, physics sleuths and inquisitive souls, and welcome again to yet another lecture of dynamic gravity. So, today we're gonna dig deep into the world of neutrino oscillations and try and figure out what's going on here. I've been promising this lecture for a while now, but I haven't delivered because it's turned out to be quite the thorn in my side. There was a lot of things that I had to figure out and hash out the hard way to figure out what the hell is most likely going on. And I'm still not 100% convinced in a Neutrino oscillation. But what I put forth to you is if it is real, this is the way it has to work, according to my theory of gravity, or it won't work at all. Alright? That's the deal. So, we're going to dig deep into that today. And we're probably not even going to hit rock bottom. Like, that's the sad part. I always shake it. So, we're probably not even going to hit rock bottom. Because this is so deep, and I don't think I'm at rock bottom yet. There's a lot going on with this. This really pushes my theory to the max. Particles, ultimately what the hell's going on, and explaining everything. Okay, it's really something, and this is probably going to be a really fucked up long lecture that nobody's going to enjoy unless you are masochistic, and maybe in which case you will. So just simmer down. Just take all that high energy and just put it in the box and take that box down to this shit store and sell that shit and get rid of it for a while. Just simmer down, grab a drink. We're going to be here for a while. It's going to be quite the doozy, I promise. And we're probably not even going to hit rock bottom. I'm probably going to have to do another lecture about this sometime in the future to resolve everything. If I feel the need. We'll find out. Alright? So, that's the dealio. Cheers. Alright. So, I just want to start with I made a prediction like a few months back that I believed towards the end of January, beginning of or end of December, beginning of January, there would be an earthquake in Jerusalem that would destroy the Dome of the Rock. That has not happened yet, but I would like to point out something that did happen. Here are my X is the only social media I have and I've had for years now. It's dynamic gravity on X. That's me. I got a few three communities that are mine that I felt needed to have a presence in this world. And of course, one of them is the Great Tribulation, where I archive everything that I find where I'm like, okay, this is probably related to the Great Tribulation. So here's some things. And of course, you see, here is one that happened a few days ago. 15th, and we're at the 19th now, so 4 days ago. And we had a 4.2 earthquake in Israel. So, this by no means is confirmation of my prediction. Not yet, it's not. But if you were thinking that I'm stupid and full of shit and I don't know what I'm talking about, you might want to hold your tongue for just a little bit longer to see how this month finishes. Because a lot of times when there's an earthquake, there will be another earthquake a couple weeks later. Not saying there will be in this time, but I do believe 100% with all my heart that an earthquake is coming very soon, any day now, that is going to destroy the dome of the rock. Let's find out if I'm right. Time tells no lies, baby. None at all. So, that's the dealio. We'll see how that goes. And I just want to throw out there, if you're a human being and you're alive, you probably want to stay that way for a while longer. In about 8 months now, Putin's going to wake up. I don't know why. Maybe someone assassinated someone close to him. Maybe he's losing the war and he's not going to be able to take it. Maybe they try and kill him and he gets pissed. Who knows? He's going to find a reason. So the Bible says. And he's going to use nukes against all NATO countries, like he's promised time and time again. In fact, if we go back to our channel here, we can see just a couple days ago as well, Putin's top advisor said Putin is 100% going to use nukes in about a year from now if the war is not won in Ukraine. I say 9 months. His advisor says 12. We'll see who's right. Do I have your fucking attention yet? So, I'll definitely make some more videos going into great more detail than I've already made about this subject, because it's very important, the most important thing in all of humanity. The death of 2/3 of the entire planet because people are fucking retarded and can't read the room and don't want to follow God. Okay. Here we go. You're on the fucking ride whether you like it or not. Here we go. So, I guess we should begin. Because if we don't, it's never going to get done. First, to understand neutrino oscillation, we're going to have to understand what a neutrino is. I know what a neutrino is, but I'll admit I never took the time to figure out exactly the architecture of a tau and muon neutrino, and a tau and muon electron as well. I just didn't do it. Because I didn't feel at the time I had quite enough information to really lock down and solidify it. And I'm still not 100% sure if I do yet, but I'm throwing what I got in there. I'm doing this decompress because it's so much information. I just can't. It's getting to be too much for my head to handle right now. I gotta dump some of this shit. So, neutrinos are indeed a elementary particle, meaning they're not made of anything else. That's what they're not. They are 100% just a thing, like an electron or an up quark. Okay? Every fucking other particle here is not elementary. The standard model is a fucking lie, and that's one of the reasons why these asshole physicists, after 100 years of stagnation, still can't fucking find their head out of their ass. They can't do it. Because they're lost in the sauce of all the bullshit and lies, like general relativity, constrained space-time, and the standard model. Now, I know some of you might be like, "Whoa, you're putting out some crazy shit, Sean. You're you're starting a war with all of physics, and you're taking out the standard model and general relativity." The war has been waging since I took this mission on in college. And I hate to break your fucking heart, sunshine, but it's over. I won. It was more of a mass execution than a war. But when your enemy is completely retarded in all ways, it's the way it tends to work out that way. Now you might be like, well, who the fuck are you? Cool. Explain who I fucking am. I'm the guy who created dynamic gravity. The only theory of gravity whose math perfectly coincides with every observation ever made. Get fucked, general relativity. You ain't even close. In fact, you're 90% off the mark, which is why you have to invent dark matter and dark energy to complete your circle of bullshit math. My math works. Still want to have this argument with me about whose dick is bigger? Mine or Einstein's? So I went on. And I said, well, if this is the way gravity works, I can use this to figure out what everything is if I can just get a beat. And I worked and I worked, and God blessed me, and He gave me a beat. And I didn't let that shit go. And so I figured out everything, how all particles and all matter and antimatter, what they are and how they're made. Okay? But I didn't do the tau and muon, neutrino, or electron. Those are the only particles I didn't hit because, as I said, I wasn't sure and I didn't want to pretend like I was sure until I was. And I'm still not 100% sure, but I'm pretty fucking sure enough to share what I got with you. Okay? So, that's the deal. Up quark, elementary particle. Electron, elementary particle. Neutrino, elementary particle. Down quark, just an up quark and an electron that combined. It's a fact. These are up quarks combined with various combinations of antimatter and whatever and blah 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 to get more larger particles. They're not elementary, but stick together. Like an atom, sort of. In a way. Like a proton. They'll stick together like a proton. Okay? Or a neutron. The muon and the tau are also like this. They incorporate the basic version of it, like an electron, but they have other things mixed with that electron, with like antimatter and other particles that create the muon, and this is why the muon is so much larger, and the tau are so much larger than an electron. It's not a native particle, okay? It's not an elementary particle. It's a combination of shit. We're going to get there sooner or later. Okay. So you might be saying, okay, Sean, make it make sense. Speak it to me like a fucking third grader if you truly understand it that way. Make this make sense. Okay. So, okay, so we have an atom, okay? We have an atom. We have our neutrons and our protons in here, which are made up of up quarks, and down quarks, which are made up of up quarks and electrons, okay? And our electrons over here, and they are all these particles. Every single one of these, the elementary ones, are best described as vortexes, okay? And one of the biggest obvious direct nods to this is it has long since been known. It's called the Biot-Savart law. And it governs the mathematics of a vortex, how it's created. This mathematics is also unanimously used to describe the behavior of an electron. Why the fuck am I the first person in humanity to propose the ideal that electrons and all particles are vortexes, even though we've been using the exact same mathematics for both? Okay? Look. Okay? The Biot-Savart law. It works for both Yeah, magnetic field, producing current flow, and it also works for vortices. And it doesn't like it says it here, but it is. It's the same thing for vortices, and just in case you don't believe me, vortex filament, all with the Biot-Savart law. Okay, this is a fact. Okay, vortex filament strength using Biot-Savart law. Okay, I'm not making this shit up, guys. I'm not like all those other assholes who don't fucking know. Okay, I've told you my whole life, I don't know everything yet, but I'm working on it. We're quickly approaching the day where I do know everything, and I'm not gonna fucking pretend like I don't. I told you I didn't know everything when I didn't know everything, and now that I do know everything, I'm not gonna fucking lie to you and say that I don't. I know damn near everything. Thanks to God helping me out with his nods here and there, okay? I'm a pretty clever guy, but I don't think I could have done it all by myself. I'm pretty sure God helped me a little bit, alright? That's the deal. So, you're like, okay, particles are now vortexes. How does that fucking work? Okay? Well, the vortexes have funny things, okay? The faster a vortex spins, the more stable it is. So when you have a vortex going at like a percentile of the speed of light, like 2% the speed of light vorticity, spinning, it is going to be incredibly stable. It's not going to be like a flimsy smoke vortex ring that you can just maneuver and flip apart because it's only going like, a couple kilometers per hour. These are very fast, very stable, and they're very strong. What we would consider an elementary particle that is the essence of mass itself. Okay? So, you're like, okay, these things are particles. How the fuck are they made? Okay. Right? And you see, with these particles, you can maneuver them, you can make them bigger, compress them small, do all sorts of shit depending on what pressure you're putting on them, okay? Just like electrons. When they're in their native state, they're like a giant cloud, what quantum mechanics likes to call a wave. But the instant that they interact with anything, they start going more and more to a particle point, the more interaction that they're on. Just like the double slit experiment says. It's a wave when you don't fuck with it, but when you start fucking with it, you get particles. That's what I'm fucking saying, dude. That's dynamic gravity, bro. That's what I've been saying for years now, but nobody wants to listen to me because I'm a nobody. Okay, cool. I'm a nobody who knows everything, and you're somebody who knows nothing. Let's see who wins. Okay? So, what happens is you got these particles like electrons. An electron will create more electrons. Whenever, say, an electron comes and it absorbs that electron, it changes the charge differential of this. So this now has to find equilibrium. So it radically fast goes boop closer, not further away, closer to the core, the nucleus of the atom. And it becomes unstable. And so it immediately bleeds off that energy absorbed and goes right back. And this popping motion of the vortex, which is a particle as we can call it because it's in a particle form, going so rapidly fast, creates another disturbance in the electric field that it's in, which is also in the presence of a positive gravitational field that we call a quark positive electric field. What currently is what science describes it as, but really that's the gravitational field, is the positive electric field emanating from the quark. Okay. Nobody knows this because nobody's really been able to do a whole lot of experiments on just quarks, as they're the most unstable fucking particle in the world. Even protons, which have an electron in them in the form of down quark to stabilize it, is still one of the most unstable particles we know in all of physics. Can't do any fucking science with that. Alright? This is the deal. So, electron will absorb electron and then rapidly go, and and it will shit out another electron because it creates that disturbance with the right-hand rule and everything in electric field with the positive field. Combine the two together, you have disturbance. Shoot out another electron. So all electrons are made from another electron. Now you might be asking, well, who made the first electron? I don't know. God. If that's where you want to take it. I don't know. All I know is I can explain the universe being made after the first atom has somehow come into existence. From that point on, I can take over with dynamic gravity and explain how the entire universe proceeds. But I can't get to that very first particle yet. I mean, I can do various tricks, but I don't know. I'm just guessing at this point. I'm trying to guess what happened 100 billion years ago. And it was probably more like 100 billion. They want to say it's like 15 or 30. No, it's definitely much longer. The age of the universe, much longer. Definitely 100 billion at least. Probably could be 300 billion, bro. Could be a long, long time, man. Because you got to get that first particles made, and that could take forever. Okay? Unless you got a guy like God around to make it for you. But then who made God? What is he made of? Obviously not particles, but what is it? Now we're into the realm of the unknown. Let's not get too crazy with that. Okay? So, quarks, they do the same process. They call it right now the strong force, the strong nuclear force. Maybe it's the strong nuclear force, right? And that is the interaction of the quarks pulling the nucleus together, okay? But really, what that is actually the up quarks, 3 up quarks and a proton fighting over the one electron. It's a never-ending struggle to see who gets it. Only one person can maintain it in one brief second in time, and they all fucking want it. So they're all fighting for that. And that never-ending struggle is what they call the strong nuclear force, okay? And they use these things called gluons with color change to change the particle, to change, because it changes the up quark to a down quark as it moves around. It's a fucking electron, asshole, that's in the middle of that shit. And when it moves from one down quark to the up quark, that up quark now becomes a down quark, because now you've made a down quark with an electron and a quark. And then it fights constantly over and over. It's so fucking simple, and it blows me away that no one on this fucking planet understands it. It's like you guys invent all these radical bullshit things like string theory and quantum mechanics and all these crazy fucking unintuitive systems that do not exist anywhere in nature, but you stick to that shit instead of going with the obvious. Okay? Humans. Crazy. So, the nucleus, the way that it creates more up quarks is when the up quarks, they become entangled for a brief split second in time. When you have the one up quark that steals the electron and becomes a down quark, the other up quarks will become entangled for a brief second in time before they are able to wrestle that electron away to keep the cycle going. Okay? And sometimes these up quarks, when they're entangled, will interact with other things near the atom, like other protons, other things, other electrons, whatever. And if they get enough energy that they interact with, pulling them away from the core, then they also create that snapping motion, which now creates another vortex of what it originally was, which is an up quark. But because you have 2 up quarks, one that's entangled and the other that's normal, and the entangled means it just goes around and reverses itself like in a chiral way to efficiently fit in the space, okay? And then when it goes to make that snapping motion to create vortexes, you don't get one vortex coming out of that, you get 2 vortexes, because you got 2 particles that are moving in that motion in the field, okay? So you get 2 particles. One will be a normal quark, another will be an anti-quark, because I did this in like my 3rd paper when I explained all this shit, okay? And I have it in all my papers linked in the description if you want to read them. I might have to make another one for fucking Oscillations soon. We'll see. So, and you get a regular quark and an anti-quark to come out of that. Because the entangled one, as you're pulling it against its current flow. And the very definition of an anti-charge is it gets pulled against its current flow. Okay? That's what antimatter is. It's regular matter that's charged, but it's charged in the exact opposite way, because when it was made, it was in the opposite configuration. So it was pulled against its momentum, where the normal quark was pulled with its momentum. And electrons do this too. This is how positrons are made. Electrons will share an orbital, one up and one down, and if you get enough energy to disturb them both, you get two new vortexes, one electron and one anti-electron, to come out of that interaction. Okay? So now you know how electrons and quarks and anti-electrons and anti-quarks are made. Now let's go into neutrinos. Neutrinos are where things start to get kind of fucking weird. Okay? And it's not weird that we can't explain it perfectly well. It's just, it gets harder to understand it with the mind. Okay? So, the way neutrinos are made is you will have a radical reorganization of the nucleus, the positive nucleus of the atom. Okay? This could occur from fission or fusion, or even, a particle bombardment. Anything where you are causing the internal structure, the nucleus of an atom, to shift for whatever reason, bloop, has the possibility. During that shifting, there can be snapping motions of the quarks, okay? Because they're in protonic form. So, what do you get? If you have a quark that is not entangled, then you will have, during that shifting process, if it bounces back just right, which apparently does when you have a lot of fusion or fission going on, because this is when neutrinos are made mostly, you now have a neutrino that's made. Okay? Think of it like if you make an electron, bloop, bloop, do the motion, the snapping motion, it makes an electron. Because of disturbance, it creates another vortex identical to that, and that electron gets shut out because of the electric force resisting. You get two negative objects and one's got to go. Fuck you, get out of here. As soon as it's made, okay? Neutrinos are just like that, only slightly different. And that because it's made from the quark being snapped open like that, you now have a positive variant of an electron. But it's not positive like a positron. A positron is the reverse current of an electron. And that's all. When you put the two together, they explode because they counteract and whatever. That's what happens when you have a positron and electron that combine. A negative current and a positive current. Okay? A quark is different. It is not the positive form of an electron. It is a completely different thing. The gravitational field. It's not made from the electric field. It needs to be in the electric field to make a neutron, I believe. I don't know why that is. We're not at rock bottom yet, but that appears to be the case. But it's the positive quark snapping motion inside the core of the nucleus when it adjusts during a fusion or fission process that creates the snapping motion that creates more vortexes, just like the right-hand rule does with the electric force. The gravitational force has the exact same rules it follows. This is why people have just assumed that the quark is the positive form of the electron, and the electron is the negative form of the quark, even though the charges don't add up and both have their matter variant, which is truly the negative charge of it. But people don't think. I don't know why. They just don't do this. Okay? So, a neutrino, is not the positive form of an electron. The electron is the smallest morsel of a vortex stable field in the electric field, caused by electric field. A neutrino is the exact same for the gravitational field, which is positive compared to the electron. So, what I'm trying to say is neutrinos are not neutral. They are actually positive. But they are positive in the same way that gravity is positive, like a gravitational field. Alright? It's hard to measure a drop of water when you're at the bottom of the fucking ocean, drowning in water. Okay? It's like, well, but why can't someone just put a drop of water over me and it drops down through the ocean to me and I can measure it? Because you're measuring a drop of water in an ocean of fucking water. Do you not see the problem? This is the reason why there's so much confusion when it comes to protons and the gravitational field they emit. Because we're drowning in the gravitational field. You can't really measure a gravitational anomaly when you're drowning in the gravitational field. So, they assume that the particle has no charge. Okay? But it does have a charge. It's positively charged. And you're like, okay, Sean, so it's positively charged. Then why does it shoot through so much matter? Well, because it's positively charged. And matter, as we know it, has electrons, which means the outside of it is negatively charged, but it has a positively charged core. Okay? So you have a neutrino shooting literally like the speed of light, maybe faster, because they do have the possibility to go faster if they're made like during, let's say, a solar on a star, right? And the star has a gravitational field pushing on that positive, and it's made of a gravitational field. It's going to accelerate a little faster, okay, for at least a brief period of time until it finds a stasis, as like electrons do too. So when they say we've measured neutrinos like just a brief millisecond coming in faster than they should have, totally possible if it was made from a source that has a larger gravitational field than the Earth's, because it accelerates that brief second as it goes up, but as it comes to the Earth, it decelerates for that brief second. All right. So when you count the two together, if the source is larger than the Earth, you can absolutely have a neutrino go faster than it should. Or even if you do weird games created on Earth, use the Earth's gravitational field to do something weird as possible. Okay? But ultimately, neutrinos, they are affected by gravity, just like electrons. It's just in the opposite manner. But they also do experience drag force, so they are also limited to the speed of light. Okay? And that's just simply because the faster it goes, the more of the gravitational field it encounters, and the more resistance. And once you get to the speed at which the gravitational field propagates, which is the speed of light, now the energy needed to exceed that goes off a cliff, straight up. And you're like, well, fuck that, dude. Now I need like infinite energy just to get like 1% faster than the speed of light. That's why. It's drag forces from the gravitational carrier. And I have proved that gravitons is a thing and possible, but that does not seem to be how gravity really transmutes itself and propagates, okay? The way it actually does is just simply as a field, okay? It's just simply a field being generated out through virtual photons. And I wish I could give you a better answer than that right now at this point in time, but we would have to do some advancement into field theory, understanding how it operates based on the premise of dynamic gravity to really crack that nut. But we're down. There are no more particles. It's just a field that is conveying gravity. The field of the proton, the protonic field. Okay, that's gravity. Just like you have a field emitted by an electron is the electric field. Same thing, brother and sister forces. Even though it's probably not the best analogy because while they probably are related in some way, they don't appear to be truly brother and sister like an electron and a positron, if that makes any sense. Or maybe that'd be more like identical twins, good twin, evil twin, I don't know. It's just, it is what it is. All right? So, now that we understand what an electron and a neutrino are and how they're made, let's take this and let's dig fucking deeper. And now let's go into taus and muons. Okay? First, though, let's burn a little incense, get a little good karma up in here. I think we need it. Because this is going to get crazy. I probably need to refresh my drink, too. Okay. So, we now know what neutrinos are. And we know that the larger neutrinos are a compilation of other particles. Okay? So, okay. And here, I think this is hilarious. This is one of the three methodologies they can use to detect neutrinos. Okay? And this one is what they use to detect the electron neutrino, the elementary one, the smallest one that I showed you. Okay? And it's just funny because they say that it's a charge interaction between the neutrino and the atom. So I think that's hilarious that they're like, it's a chargeless, particle, but yet there's a charge interaction whenever it comes to the electron neutrino interacting with it. It's just fucking weird, dude. It's just, it just seems contradictory. I'm sure they have some obscure, highly detailed, involved excuse to explain this, but it just seems kind of stupid now, a neutral particle with no charge is having a charge interaction, creating a charge current as it flies by things, and that's how you're measuring it. It's just fucking weird, dude. So, neutrino oscillations, okay? First predicted in 1957 by Pontecorvo. Interesting, I didn't know it went back that far. Okay? Now, the reason why they think the neutrino oscillation is a thing is they're trying to explain why it is that they expect to see 100 neutrino events in a certain period of time, but they'll only see like 30 or 40. Okay? And they weren't sure why this is. And so they came up with various different reasons why this could be. And one of the reasons is like, well, there's 3 flavors of neutrinos. We're only seeing a third of the neutrinos. What if the neutrino is somehow converting itself into the other neutrinos? And that's why we don't measure them. Okay? It's an interesting scientific, thought. And so here's a dude that they gave the Nobel Peace Prize in 2015
Dear
for this.
laureates, ladies and gentlemen,
Okay.
Otta, almost, but since there are so many
Of this talk is shown here.
And here's a guy Now, for some reason, probably I'm guessing because he specifically worked on those projects. The only projects he really refers to are like Camino and like Super Camino, and then I think another one, and he was awarded the Nobel Peace Prize for proving that neutrinos oscillate. But all of the projects that he worked on, and in fact, dare I say, as far as I can tell, every single neutrino oscillation project to measure neutrino oscillations, aside from one, which we're going to go into, all have done the same thing. They're all measuring, they're creating muon neutrinos from a reaction. They're creating like pions, all right, and a particle accelerating. They're accelerating protons after they strip the electron away, and they're hitting it with something like lithium, aluminum, gold, whatever. And this is creating pions. And these pions, I'm going to show you these are in a minute, they decay, and then you get a muon neutrino out of these, one of these, okay? And then other things, okay? Now, what they measured is that they are creating muon neutrinos. And they are trying to measure this beam of muon neutrinos that they've created from the particle accelerator, okay? But they're not getting the amount that they should. They're only getting like half, okay? Or a third or half. The numbers don't always add up perfectly. Okay? So, they have, what they're measuring is muon neutrinos. And they're not getting as many as they are. But they're not measuring electron neutrinos, the actual elementary particle of it. They're measuring the combination they should be getting, and they're not getting the right numbers, okay? And so they say, well, if we were to assume certain things, like neutrino oscillation, is a thing. Like here's one of the events he worked on, okay? After more than a year's studies, we concluded that this is a muon neutrino, is what this VU is. And the VE is an electron neutrino, okay? So, what they're saying is that we expected 144 events of muon neutrinos, but we only got like half that, more than half, okay? Because half would be 72. They got 85. Now remember, what they expect to see if neutrino oscillation is truly on the level like they say it is, then what they should see is a third, okay? But that's not what they're seeing, okay? They're seeing more events from the electron neutrinos than they expect, but not that many, just barely a little bit more. And they're seeing a lot less events from muon neutrinos, but it's not a third less. It's not even half less. It's still more than half of what they expected to see is what they're measuring. Okay? So, all of the experiments, with the exception of one, This is pretty much the game they're playing. They're creating what they can make, muon neutrinos, in a reactor. Not a reactor, but a particle accelerator. And then they're trying to measure those events. And they're not getting as many as they should, but it's not exactly a third of what it should be if neutrino oscillations were correct. And they do notice they are getting a few more neutrino, electron neutrinos, the actual elementary form. And they haven't measured the tau neutrinos, so that isn't even a factor in this. They're just assuming that it's going to come out the numbers they want it to be. I'm not going to lie. I do not like this Nobel Peace Prize awarded for this yet at all. I do believe they're putting forth a convincing argument that neutrinos are being converted from one form to another. But I do not believe the argument is as conclusive as they believe to prove the theory they have that the neutrinos freely oscillate between all the forms equally whatever the fuck they want. Okay? It just doesn't add up. Alright? Like, and he even says here, he's like, listen, here's what we think would be happening if it were a neutrino oscillation. But notice, the only two things they're measuring that are oscillating are the muon neutrinos and the electron neutrinos. There is no tau neutrino in here. They're only measuring as though it oscillates between the two of them. This... I just don't like it, man. I don't like how they're going about this. There's a lot of assumptions going on here. There's a lot of things that aren't being measured that need to be measured. And they're trying to prove a theory that they want to be true. I just don't like it, man. And this is why I have kept out of the neutrino oscillation game for so long. Because I'm not 100% convinced when I see shit data like this. Okay? You're telling me, okay, well, we believe that there's oscillations going on between muon and electron, and tau, but you don't even have the tau up in this picture at all, and it's just a basic one-to-one. I don't like it, man. I don't like it. And I'm sure they'll give you some crazy, in-depth, ridiculous answer that does all these crazy gymnastics and whatever to you just do a couple backflips and do the splits and blah blah blah, and look at it from that perspective and everything adds up. Yeah, I guess if you're gonna fucking do backflips every time you're fucking in love with something, I guess. I don't know.
If propagate further, disappear again, reappear again. And if muon neutrinos disappear, then tau neutrinos appear. So this is the neutrino oscillation.
See, and you heard what you said. He said when the muon neutrinos disappear, taus appear.
And one important
but he doesn't even have tau in this bitch. It's only the electron and the muon. He doesn't even have a tau in here. But he's including it as an assumption.
Mention that however, if
all right.
a neutrino is 0.5,
and this is when he got the Nobel Peace Prize. This is the thing that he presented. He's like, this is why I deserve this prize.
than the fiducial mass of Kamiokande.
All right, and he's a more super chemical.
Event topology.
Okay.
Fusion.
And I guess here's what he wanted to try and prove. This dip, and they were able to prove it was a dip, but they weren't able to prove that it was what they wanted it to be.
So you can realize that
right.
that model of elementary particle physics
here's
probably.
Okay. So, Sudbury, 20 years of his work. He feels lucky. Okay. He thinks in 1988 they proved neutrino oscillations, and that proves they have mass. Maybe. Discovery of neutrino masses opened up. Okay, we're going back into neutrinos have mass. Okay, and there are still many things to be observed in neutrinos. We don't buck it out. We're making a whole lot of assumptions, is what he's basically saying. Okay, and the one thing that they did come away with is an unexpected muon neutrino deficit in the atmospheric neutrino flux was observed. Okay, so what he's saying is the one thing we did observe that we know for a fact is we measured, we know there were muon neutrinos that were made either from cosmic rays or from a particle accelerator. Both will do it. And we are positive that we are getting a dip. We're not measuring as many as we should. That's the one takeaway that he can 100% bet money on. That he's like, this is it. This is the one takeaway we know for a fact. If there was another one, he would have put it here. At least he should have. He's a real scientist, right? That's the only takeaway he got that he can prove with facts. We should have this many muon neutrinos, but we don't. That's the takeaway from this whole 34 minute extravagant thing on him justifying why neutrino oscillation is a thing when he picked up his prize. Okay? Now, you're like, okay, Sean, they're telling me that all the neutrino oscillation experiments they used to prove neutrino oscillation is true really only proved that neutrino oscillation occurs with muons. Bingo. Except for one. Okay? Now, that one is, let's see, look, here's all the major neutrino oscillations, okay? The first one, neutrino, they figured out there's a deficit in neutrino electrons. They don't know why. Okay, they couldn't measure anything else. All these other experiments measuring everything except for this bad boy right here. SNO. Sudbury Neutrino Observation from 1999 to 2006. As far as I can tell, they're the only ones who have not played the muon neutrino game. Okay? They said, we're going to try and measure all three neutrinos coming from the sun, the fusion occurring in the sun. And we're going to see what we get. Okay? So, this is the experiment. The only one, as far as I can tell, that really gives hard evidence of their theory of neutrino oscillation as they present it. The only one. Keep that in mind. All the other ones prove an aspect of neutrino oscillation. They don't prove the whole thing. They only prove an aspect. This is the only one where they're like, we tried to measure all the neutrinos coming from the sun, and we only got a third, like we knew we would. And so we tried to measure all the muon and tau neutrinos, and we ended up getting more of those than we would expect. And if we add them all together, roughly it adds to be what we would expect from the sun. Okay, that's a pretty compelling argument. And I admit I'm kind of at a loss for words to describe exactly what is going on here. Because when I break into exactly what tau and muon neutrinos are here in a minute, you're going to find out why. Okay? I just want you to know. Excuse me. Drain Brammers from war. This is the only experiment where they say we think we can prove neutrinos oscillate freely between all three. Okay? And there are some problems. Okay, here's the charge current interaction I was talking about, and here's the other one, the neutral and the electrostatic scattering for the that all three neutrinos will do, so they can measure the tau I don't think they can measure tau specifically. And maybe they can, but these ones I think measure, it's a combination of all three of them. All three of them are equally likely to do this. So they don't know what kind of neutrino did these two processes, but they know that only the electron neutrino can do the charge current. And keep in mind, the electron neutrino is the one, the absolutely one, that according to my dynamic gravity should not have, it's an elementary particle. It should only be charged up to what is charged up, okay? And if it was truly chargeless, why is it creating a current charge interaction? It's really fucking weird. Alright, but let me come down here. Other possible analysis, alright? The S-node detector would have been capable of detecting supernova when our galaxy had been occurred. Detector been online. Neutrinos emitted from supernova released earlier than photons. Okay, so this neutrino detector is going to measure neutrinos from everything, every source. They're just trying to get the ones from the sun, made from the fusion and the sun. They're not trying to get the ones made from super neutrino or super fucking supernovas. They're not trying to get the ones that are made from cosmic rays, okay? But they are going to get those because those are neutrinos that exist and are there. That's a fact, okay? So, now their explanation for this is, well, but due to the limited size of the S-node detector compared with a super K, a low cosmic ray neutrino signal is not statistically significant to neutrino energies below, blah, blah, blah. That's an assumption. They don't fucking know. That's an assumption that makes everything else that they believe work out nicely. All I'm saying is know when they have made an assumption and when they are presenting factual evidence that can be proven in a laboratory. Just know the difference, okay? So, they could have been measuring neutrinos from all sorts of crazy shit, okay? And they would not know. Now, I'm not saying that they're wrong on this experiment. This experiment is compelling, okay? And like I said, I do have difficulty explaining the results on this particular one. But just know, this is the only one. It is entirely possible there are all sorts of things going on with the events that they measured here that are not on the level of what they expected, and that conflated the data. Entirely possible. Just keep that in mind, okay? And I mean, I've tried looking into, papers released from this shit, being like, okay, what exactly were the measurements they, expected to get, and what did they, get? And then I think here's what they expected. They say like 5.21 or something for regular electron neutrinos, but they only measured I think it was 34% of that, which works out pretty nicely for their theory that they should measure 33%, 33%, really, really good, okay? So, the Silberg neutrino oscillation result and provide conclusive evidence that neutrino oscillation change flavor, solving the long-standing problem. Okay, this is what they expected to get, but what they only got, as they said here somewhere, it's 34%. I don't remember where it's at. Yeah, and here's the different techniques I was talking about earlier. But I do admit, this experiment is compelling, and I don't want to shit on it and say that it's wrong, because I don't know 100%. All I'm saying is it's the only one, and all the other ones really don't tell you what you need to know. I personally don't feel like this is a solved issue yet, but that's me. Because I know how neutrino oscillation would have to work if it's real. Okay? And we're about to go into that right now. And that's going to be a fucking doozy. Let me tell you what. I hope you fucking got your drinks and fucking everything, because this shit is going to be really fun. The mountain. の立ち嵐のか。Okay. Always gotta go for the 50-50 mix, the mixer and hard liquor. I just think it's the most effective and efficient. What do I know? I was only a bartender for like 7 years. I'm sure I'm wrong. Okay. So, I thought this was really interesting as hell. Unonium. I didn't know this was a thing until like yesterday. I'm like, what the fuck is this? They actually can make, this is a real thing, unonium. A complex and what's an electron orbits a positive muon. I didn't even know muons could be positive. I'll be fucking honest with you. I did not know. But yes, muons can be positively charged or negatively charged. And we're going to break down what the fuck is going on with that. It's going to be fantastic. Right? But munonium, it's a thing. And they say it acts like hydrogen, light hydrogen, because it's very similar to light hydrogen. So, super cool. Super cool. And I'm sure this would have some super cool uses somewhere in science. If we could have like a bottle of this, who knows what it would do. Right? So here's what we got. Here's an accelerator, okay? High energy protons generated by particle accelerator collide into carbon beryllium target. Proton accelerated into carbon. Hits. Knocks a neutron out. Okay? And what it also knocks out, or creates rather, is a pion. Okay? And you're like, what the fuck's a pion? And this pion decays into a muon. Okay? A positively charged pion decays into a positively charged muon. Okay? So, what we got? Okay. So here's a pion. Okay? A pion is like half a proton. It's like a proton that got split. But it's not exactly half. Because some shit happens. Okay? Remember how I told you the way you create a quark and an anti-quark, which are always created at the same time due to the nature of how they're made inside the nucleus of a proton, inside the core of a proton. Okay, you have the bloop bloop, and when they're entangled, you get a quark and an anti-quark spit out. Okay, if you have a traumatic enough event like bombarding, beryllium or carbon with protons at like the speed of light, damn near. You're gonna have all sorts of crazy snappy motion going on all around this fucking atom, depending on how it got hit, okay? And that is going to make a pion. Okay? A positive pion. Which is going to be like an up quark. And that's not a down quark. Okay? That's an anti-down quark. So that is an anti-quark, which is also bonded with an anti-positron. Meaning that if it was made, like from, an atom being smashed by a proton, that you have this traumatic event where it's hitting this atom and ripping it apart, and all these things are being redistributed through equilibriums, creating all these snapping motions, like electrons that are entangled, creating an electron and a positron spitting out. In the meantime, you have the core being ripped apart and reassembling itself, which is creating neutrinos. And then you've got up quarks and down quarks, not the up quarks and anti-up quarks that are being made at the same time. An anti-up quark can bind very quickly with an anti-electron. if they're made at the same time. And now you have an anti-down quark. Okay? Because remember I told you, down quark is always an electron and an up quark. But an anti-down quark is going to be made of an anti-electron and an anti quark. Okay? And then, because these are opposites of each other, they're going to decay very rapidly. They're going to counteract each other and then turn into other things through various interactions, and that's going to cause this whole core to split and do all sorts of weird shit. Okay? And it's going to cause a very energetic reaction. Keep that in mind. This, you would think, because it's smaller than a proton, it's going to be less energetic, but there's a whole lot of energy stored in this because it's antimatter with matter. Okay? It's a lot of energy. It's going to be created and released and do sorts of weird shit, and it's going to have all sorts of things. There's positive energy right here and the fucking negative, but you got the positive, it's a negative positron, and blah 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 blah. It's fucking, it makes your head spin. It makes your head spin trying to fucking get a grip on this shit. But it's the way it is. Okay? So, love metaphysics, great channel, shout out. But he's basically saying, shoot a proton into lithium, create a positive pion, which you can have positive or negative pions created from this. Okay? And to show this, he actually has some evidence of some sort. Yeah. So 80% of the collisions, when you slam a proton into lithium, beryllium, carbon, gold, aluminum, where the fuck they're using, they use all sorts of weird shit to create pions and particle accelerators. 80% of them from this particular reaction of lithium 3 plus are going to be positive pions, and the other 20% are going to be negative. Okay? Break. Okay. Hopefully, no more episodic episodes of my epilotic dick from my drain brand engine in Iraq. But I don't get a fucking say. It comes when it comes and it goes when it goes. C'est la vie. Isn't the game of death dandy? So, here is my work that I've accumulated so far. Okay, if we go here. I've accumulated this over a couple of months. I'm just trying to figure out what the fuck's going on with this shit. I gotta archive stuff, right? So, a muon will decay into an electron in two types of neutrinos. Okay? The electron anti-neutrino and a muon neutrino. Okay? Is the most common decay mode. And that means that's pretty much what it is. Okay? Now, you can have other decay modes that basically happen because these particles are interacting with other things that are around that are creating other things. Okay? It doesn't mean that it can decay into different things. It's one thing, and it will decay into what it decays, what it's made of, when it gets dispersed of. But it will only decay into what it can decay. But like I said, the decay products, as it decays, can interact with other things, which is why they say, well, there's different decay paths. There's only one decay path for every fucking particle. The problem is, when it decays, it can interact with all sorts of crazy shit that's around it, like when you're in a particle accelerating, slamming thousands of protons into a fucking target, and you have all this crazy shit happening on that can be interacting. That's where the confusion comes into play. That for some reason, particle physicists just don't understand. I don't get it. How someone so smart can be so stupid. But welcome to the human race. All right. So the electron transforms into a lighter. Okay, so it always breaks apart into an electron neutrino, and a muon neutrino. Okay? Now, this comes from a muon, which we know comes from a pion. Okay? Pions decay into muons. Okay? But they also decay into something else. Alright? And here's the difference. You got a positive pion is a up quark plus an anti-down quark, and a negative pion is a down quark plus a anti-up quark. Okay? And I find it extremely interesting that the most prevalent version of this is this one, as this should be the most hardest to get. But there must be something going on with the orientation of the atom that's making this more conducive. It happens. Orientation's a motherfucker. Alright? So, the muon will decay into an electron. Also an electron. But there's a thing. There's something else in here that we're missing. Okay? You see, the muon is not just 3 particles. It's actually 4, I believe. But that 4th particle gets destroyed, and that's why the particle disintegrates and falls apart, because the glue that's holding it together gets destroyed. If that makes any sense. Okay? So, a muon, I don't believe, is an electron and an anti-neutrino and a muon neutrino. I believe it is an electron and an anti-neutrino and a muon neutrino and a positron. Okay? Which, remember, if we're throwing around a lot of energy, we're definitely going to be aggravating entangled states of electrons. It's the most easy to aggravate. And you're going to get an electron and a positron that come out of that. Okay? But keep in mind, the positron is antimatter. Okay? And even though it's somehow holding this muon together, in the meantime, not annihilating it, for reasons that I don't understand yet, as a muon will travel through, let's say, the gravitational field of the Earth, you have so as the muon will travel through the gravitational field of the Earth, you will have, let's see here if we can. Go here. Don't know what this was from. That was so lit. Who knows? I'm sure it was good stuff though. So, we got our muon here, okay? And our muon, we're going to say, is an electron. Just like a little toroidal vortex, okay? And then we got a negative positron, okay? And then we got an anti-neutrino and a muon neutrino, okay? So we got 4 things that are somehow holding themselves together, but it's not very stable, which is why it disintegrates very quickly, okay? Because you got an anti-electron that's traveling through, in this muon, a gravitational field of a planet, okay? And this gravitational field is going to interact with the particles, okay, as they travel through it. It's going to happen. They're going to accumulate more and more of this gravitational charge, if they can, as they travel through it, okay? And as they accumulate this gravitational charge, I believe what is going on is destabilizing the anti-electron somehow, okay? And that is the part that is holding this whole particle together. And I might be wrong. It might not be the gravitational field. It might be the electric field of the entire planet. Keep in mind, we're in a giant electric field. There's a giant magnetosphere surrounding the entire planet, okay? That's an electric field, okay? The Earth has a magnetic field, hence it has an electric field, okay? Electric gravitational field. If you're going through a planet like the Earth, you're going through both. And at this point in time, I'm not at rock bottom yet. I'm not completely solidified on which one it is that's causing this problem, okay? Could be the electric field. But something is accumulating charge with this anti-electron, okay? And as it accumulates charge, it's going to accumulate enough until it gets completely countered with enough of another field surrounding it accumulates that it gets nullified. And when that happens, these other things that are being held together by it disperse and they go free their own way, okay? And that is the deterioration of a muon, okay? And we have a tau. A tau is the same story for an electron. A muon electron and a tau electron. This is what's going on, okay? Okay? We come here. Muon decay path. Here's another decay path where they say that it spits out an electron and 2 gamma photons. Whenever you have 2 gamma photons, usually what that means is you have like a positron and an electron. They collide it. They convert it into photons, the highest energy photon they can. Gamma wavelengths, because electrons are essentially the highest form of photon energy form. Okay, electrons and photons, same thing. The difference is the electron is the highest form of it, the highest iteration, like Super Saiyan level 3, right? And you got like a photon is like Super Saiyan level 1, okay? And it's not even making a whole circle. It's just like a line, like a wave. But if it condenses to where it wants to loop around and make the circle, now you have an electron, okay? So that usually means that. So there could be all sorts of interactions happening with that. I'm not putting too much faith into that personally. Now, tau electron decay is important. The electron, it decays into an electron, as the muon does. A tau neutrino, remember, the muon decayed into a muon neutrino. Okay, so notice the similarity. You have a tau muon that is embedded into the muon, and you have you have a muon electron that is embedded into the muon, and then you got oh God, I'm so fucked up. You got muon neutrino. Okay, that's embedded into the muon, and you have a tau neutrino that is embedded into the tau. Okay, but other than that, they're pretty much the same fucking thing. In fact, they are the same thing. Okay, so the only difference I want you to know between the tau electron decay path and the muon decay path is that the muon produces a muon neutrino and the tau produces a tau neutrino. Other than that, they're the exact same fucking thing in every possible way. Okay, when a muon disintegrates, it turns into an electron and an anti-neutrino and a muon neutrino. Tau turns into an electron, an anti-neutrino, and a tau neutrino. Okay, do you see the similarity of what's going on? Okay, it's the same mechanism at play. Okay, so I propose that the tau neutrino, the tau the tau electron is also held together just like the muon electron. Okay, with an anti-electron or a positron. Okay, and then as this thing travels through either the gravitational field, the positive gravitational field, or the negative electric field, the Earth, probably the negative electric field now that I think about it, because that's going to be the opposite charge of the positron. And as it accumulates and hits enough of this charge and it accumulates it, it's going to eventually disintegrate. And when it disintegrates, the whole thing's going to fall apart. Okay? Happens for a muon electron, and it happens for a tau electron. But notice, an electron is an elementary particle with just an electron. So it can travel through the Earth's atmosphere in all ways and not change. Okay? It can get destroyed because it gets sucked up by an atom and convert it into this or that, but it does not alter what it is an elementary particle. But a muon and a tau are not elementary particles. They are made of other particles, and they disintegrate because those particles are being held together by a positron that disintegrates as it travels through the Earth's atmosphere, or gravitational field, electric field, probably electric field. Definitely one of the two. I think it's electric field, not anything about it. Okay, so this explains muons and tau electrons. Okay, why they don't oscillate, and why all they do is disintegrate in the presence of an electric field. And this also proposes an interesting experiment that could prove what I'm saying is true. If you could generate muons in deep space, void of electric fields and gravitational fields, probably mainly electric fields, then those muons theoretically would last infinitely much longer in their existence than a muon that is in the Earth's field. Okay? So my theory proposes. Maybe one day we'll be able to test that. But at this point in time, I don't think we can, because we can't really do any experiments beyond the ISS, and the ISS is still in the Earth's gravitational and electric field. Alright? So, interesting experiment. Maybe someday someone will prove out in deep space. Until then, who knows? Or if we can shield all this stuff. Maybe. Okay? So, that is the deal with muon and tau electrons. Okay? They're created by pions. And when the pion decays, it will turn into a muon, a positive or negative muon, depending on it was positive or negative pion. And then it spits out this, which is, what is this? A muon neutrino. So know that. It makes, remember when I said, if you make an anti-neutrino or an anti-electron, because of the way it has to be made, entangled, you're going to get an electron and an anti-electron. The same is always going to be true with a neutrino and an anti-neutrino. Okay? So, we've got a muon, which we know has an anti-neutrino and a tau neutrino. Okay? And it's also spitting out another tau neutrino. I'm willing to bet one of these came from entanglement and is reversed. But what do I know? Okay? And look, there we go. Yep. See, my bad. This is because it was a positive. I was bucked up in my thinking negative because that's the way my mind thinks. That's why I learned it. So we got a muon neutrino here being made in this process, and then an anti-muon neutrino being spit out here. They were both made at the same fucking time in this step when the pion decayed. But the anti-neutrino, tau neutrino, or my bad, muon neutrino, went into the positive muon particle. Okay? Are you starting to see that what I'm saying adds up? All the pieces add up into like a puzzle and fit together to give you the picture of what the fuck is going on. Okay? You're starting to see that? I'm not full of shit. I'm not stupid. I'm not crazy. I'm just proposing shit that no one else can think of for some fucking reason. I don't know why, for all the money in the world. Okay? So, just know that. That's the deal. I feel like we've covered tau and muon electrons very well, explaining what they're made, how they're put together, and why they decay like they do. Now, let's get to the big motherfucker. Excuse me. Now, let's get to the big motherfucker, which is muon and tau neutrinos, and what the fuck is going on with the oscillations. Okay? I told you it was going to be a super long and super fucking hard hitting fucking lecture. We're not even fucking near done yet. Did I not promise? Did I not deliver? This shit is fucking crazy. Okay. So, neutrino oscillations. An electron with an anti-neutrino is a muon electron. Okay? Okay. So an electron with an anti-neutrino, okay, is a muon, like, okay, yeah, and there's also something else. And an anti with the, okay, and an anti-electron and an electron, an anti-neutrino and neutrino is a tau neutrino. Okay? So, let's look at the tau neutrino pathway, okay? Tau lepton goes into an electron has an electron in it also. An electron anti-neutrino. So just like the tau, we have an electron neutrino, and an electron neutrino, and an electron, and an electron. Okay? The difference is that you have a tau neutrino versus a positive tau neutrino. Theoretically, okay? Oh man, okay. So, this is not the whole picture, okay? Once again, I believe there is an anti-electron, a positron, that is involved in this particle. It is not elementary. Okay? A neutrino is an elementary particle. It's as small as it can get. But a muon neutrino or a tau neutrino is a combination of other shit. It's not elementary. Okay? And I believe that the particle that's holding the neutrino, the tau and the muon neutrino together is not a positron, but the electron. There is a positron in there, but the electron is the particle that's actually holding it together because it's all reversed, okay? So, excuse me. Okay. So, this muon. So now, let's do neutrino muon. Okay? Yeah, I know, my handwriting sucks. I'm the worst. Okay. So, we know we got an electron in there. We believe we also have an anti-electron, positron. And we know that we have an anti-neutrino, just like the muon. The difference is instead of having a muon neutrino, we have an anti-muon neutrino. Okay? Beep, 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 pop. And once again, as this particle travels through the field of the Earth, this one, I believe, is a gravitational field, though. Okay? I believe the muon is affected and destroys itself with the electric field of the planet. I believe that the neutrino does it with the gravitational field. Okay? Because as it goes through this, once again, maybe I'm wrong. Maybe it is the electric field. I'm pretty drunk right now. And to be honest, I'm not at rock bottom with this shit yet. But let's pretend right now it is the electric field. I'm not 100% certain, okay? Say it's the electric field like it's a muon, like we think. We're not sure. I don't know for a fact yet. But I believe because that's the way everything kind of adds up, all the puzzle pieces fit together. Okay? So, as this particle goes through here, we're going to have the positron is also going to be accumulating charge. Okay? And is going to be accumulating until it accumulates and disintegrates and turns into something else. Okay? But unlike the muon, where that thing eventually accumulates enough of a field to destroy itself, and then the particle disintegrates. What's going on with neutrino is the tau, my bad, I'm so sorry, fuck, I'm so drunk. The muon, not the tau. The muon will accumulate charge. And then it will get to a point where it will transform it from a muon neutrino into a tau neutrino. Okay? Because we know the difference between the tau neutrino and the tau muon. Okay, the muon neutrino is an electron, an anti-electron, and of course an anti-neutrino, and a muon anti-neutrino. Okay? So, that then will accumulate energy and transform what appears. I'm not 100% certain of this, but we're pushing this out because this shit is too much in my fucking. As you can tell, this episode's gone on too fucking long, dude. There's too much shit to keep track of, dude. I have to dump this shit now. It's fucking making me go insane. Okay. It will transform into an electron, an anti-neutrino, and a tau anti-neutrino. Okay? And whether or not the tau still has this anti-electron or positron still involved, holding it together is debatable. Because the tau falls apart instantly. So there's really not much holding it together. So the argument that something's holding together doesn't really fit together too well. But we know it accumulates the energy as it travels through the Earth's either gravity or electric field. I think the electric field probably, because it interacts with the positron. And since this particle is held together by an electron and not the positron like the muon, it will stay together. Okay, but it will convert into something else. So now we have a proposed methodology how a neutrino muon can turn into a tau neutrino. And then the tau will disintegrate, ultimately given time, and destroy itself and turn into a neutrino and a bunch of other shit. Okay? Because when it falls apart, all this shit that comes apart and does shit. Okay? So we have a pathway where we can explain how is it at least possible for a tau neutrino to a muon neutrino to transform into a tau neutrino, and then a tau neutrino disintegrate into a regular neutrino. Which means we can turn a tau into anything we want. But notice, this oscillation does not go both ways. It only goes one way. And that's what I propose. That if neutrino oscillation is real, which it does appear to be a thing, but it does not appear to me, I'm not convinced it's as they say it is, or that it's what they say it is, or the numbers they claim are legit. But they have convinced me the neutrino oscillation is at least possibly a thing. Enough for me to take it seriously. So here I am, taking it seriously, trying to explain this shit with dynamic gravity. And here's what I got. I can explain how muon neutrinos, but not electron muons, will convert into a tau particle, which will then disintegrate into a basic electron neutrino. So we can get conversion from one to any of the others, but it does not go any which way. We cannot get a regular neutrino, a basic electron neutrino, to convert into anything. It is an elementary particle. It will never convert into anything because there's nothing for it to interact with to change it to what it is. Now you're asking me maybe, okay, Sean, but they clearly have known since the 50s that wherever it is, that we're not getting the amount of electron neutrinos measured that we should. Something's happening to them. If those are not being converted, what is it that's going on? Well, we know this. Electrons will be consumed and destroyed and converted into a new electron through the process of, remember the popping of whenever electron absorbs and goes into the field. Remember this? Bloop, bloop. All right. A neutrino is a sibling of an electron. They're like brother or sister in many different ways. So whatever can happen to the electron can also happen to a neutrino. Now, it may be much less likely to happen to a neutrino because of how the neutrino interacts with things, with its positive force, and as it's going the speed of light, you convert that into momentum. You find it has more than enough energy to push out any particle out of its way up until, like, I don't know, like, you have to get past uranium before you start having problems, okay? So, according to my theory, a neutrino will be able to shoot through pretty much anything until you start getting really, really dense matter, like beyond uranium, like really, really dense shit. And now it's going to have a problem doing that. And it's going to start interacting with things a lot more. And some of those interactions might destroy that neutrino. And that could easily account for why you're only seeing a third or half of neutrinos that you expect to see. Okay? So, I can explain what is going on, but I'm not going to lie. I'm not 100% convinced that I'm right and this is the way, so to speak, yet. I only know this. Dynamic gravity is true. And if neutrino oscillation is truly a thing, it has to be a mechanism identical to this or very, very similar to explain it, okay? It can't be in fucking wild shit. It has to be something like what I'm explaining to you right now. Only maybe instead of this, it's that. Very, very similar. Very, very similar, okay? You get it this, you get it that. So, man, I'm so fucking cooked right now. So I'm trying to say is I can explain why we're not seeing as many electron neutrinos as possible. I can explain why muon neutrinos are being turned into tau neutrinos. And I can explain why tau neutrinos are being turned into electron neutrinos. And that's about it. That's about all I can explain. If it's something beyond that, I cannot explain it at this point in time. But given the data, I'm not convinced it is something beyond that. I am convinced maybe electron oscillation or neutrino oscillation is true. They proved me something's going on and it seems to be like that. And if that is a deal, this explains it. Perfectly explains it. But like I said, there are some things that don't add up, like where they say the Salisbury neutrino observation, where they claim their results conclusively prove all neutrino oscillations go this way or that way. I'm not a fan of this because remember, this is the only experiment that claims this. All the other ones, all they fuck around with is tau neutrinos. Okay? That's it. This is the only one that claims this claim. And I am skeptical that it is as exactly as they say it is. Okay? I'm sure it's something similar to what they're saying, but keep in mind, these guys don't even know what fucking gravity is. They don't know anything. They can't calculate it. They can't do anything. They don't know what matter is. They don't know anything. These guys are fucking trapped in this mentality that matter is a fucking wave of energy, and then it magically turns into a particle, and because it's conscious, it does whatever the fuck it wants to do, and it's in the fucking box of the cat, and it wants the cat to die, or it doesn't want the cat to die. You don't fucking know until it knows. And it's just like, yo, bro, chill the fuck out, alright? You guys are fucking off the deep end with this shit. But anyways, that's what I got so far. I'm going to keep working on this because there's a whole lot. I'm definitely not at rock bottom on this shit yet. There's more. I gotta add up all the charges. And if the charges add up like I say they do, and that's proof, and I'm good. So we gotta do that. That's for me next. But I'm done. I'm cooked right now. I'm gonna fucking go throw up. Right, leave us my charges. Till next time. Peace.
Like, subscribe, submit.